Okay, so we finally have everything we need to complete the square. So again, the idea is I have a quadratic like so, right? So a nice classic, or down here, right? So we have a nice classic general form quadratic, and our goal is we want to rewrite it so it looks like that, and I can use the square root property. Same thing down here. My goal is I want it to look like x minus 8 squared, right, equals some number. So there's the goal. Here's the steps that we're going to do it, and it uses what we just learned. So step one is I want to make sure that the lead coefficient is 1. So recall, as in the last video, what I shared with you is that these two terms together represent a square that is incomplete. All right, it has a missing chunk in it. And so notice that the lead coefficient is 1. So in order to get an incomplete square picture, I need to make sure the lead coefficient is 1. So that's my first step to consider, and we'll talk about what we do. It's pretty easy algebra. Next, once we have that, we're going to isolate the incomplete square terms. All right, so let's pause here for a moment and let's kind of see these two steps in action for this example over here. So step one's already done. The lead coefficient actually is 1, so we're good to go. Step 2, we need to isolate the incomplete square terms. So there they are, right? There's the x squared plus 8x. So this piece right here we need to get rid of it. And what I mean by getting rid of it is let's just move it to the other side. So you'll notice that my incomplete square, right, the x squared plus 8x part, is now isolated, right, by itself. So that's what I mean by isolate the incomplete square terms. Now we complete the square, right? So what did we learn from the last video? We're going to take whatever b is and divide it by 2. I like to do that work off to the side. So 8 divided by 2 is 4. This piece, as I've shared with you, is very important. It's going to play some roles down the track here. So make sure you're showing yourself that step, right? So what do we do with that? Well, we're going to square the result from step 3. And recall that is the missing chunk. So we're now going to go to step 4. We're going to add this part, whatever we got from step 4, we're going to add it to complete the square. So we get x squared plus 8x. I'm going to add 16. And of course, as we know, right, as some of you have lost many points over the last summer, right, whatever I do to one side, I have to do exactly the same thing to the other. So I'm adding 16 on this side to complete the square. To balance the equation off, I have to add 16 to that side to make sure that I'm in balance. That whatever solves this equation will solve that one. So my algebra is good, and I think we're done with step 5. Step 4 is we can now factor the trinomial on this side. It should be a perfect square trinomial. And the key is it's always going to use that number right there. So this is going to be x plus 4 squared, and 20 plus 16 is 36. And so there's our perfect square trinomial factorization. What you see is we have exactly what we wanted to do. Right? I have x, in this case, plus a number squared equals 36. So all we have to do is invoke our square root property now, right? That's step 7 there. And we finish it using what we just learned earlier. So this side's x plus 4. This becomes plus or minus 6. So there's two potential answers, right? X plus 4 is 6, or x plus 4 is negative 6. Subtracting 4, we get x equals 2 as a solution, right? Or if we subtract 4, we get x equals, oops, let me write that better, negative 10 as a solution. Okay? And I know that, some of you are probably looking, why doesn't he just factor this? And I could have, right? But we're trying to learn is completing the square. But what's nice is notice that if I take x minus 2 and x plus 10 here, right? If I factor that, I will get x squared plus 8x minus 20 equals 0, showing that 2 is a solution and negative 10 is a solution. So that was kind of a check, if you would, with my factoring technique. But that is what the completing the square technique looked like. So it does have some steps, a lot to remember. Practice hard. That way you can get it down. So for the next one, let me do one more example, and then obviously I'll cut the video and we'll go do some more. So for this next equation I have to solve, I need to make sure that the lead coefficient is 1. Right now my lead coefficient is 2. So how do I change that to 1? Well, I would like to divide it by 2. But of course, mathematics being mathematics, you have to make sure that it's balanced. So I got to do both sides, and I got to do everything. So everything on this side gets divided by 2, and to balance that off, we have to divide that side by 2. Of course, that's easy. 0 divided by 2 is 0. And then don't forget there's 3 fractions here. So 2x squared divided by 2 is an x squared. I think we saw this in section, what was it, 4.8. When we divide by a monomial, we basically divide it into pieces. And so this would become 20x, and this would become plus 100. All right, so we're off to the races there. All right, next step is to isolate the incomplete square terms. Well, there they are. So to isolate it, I'll subtract 100 from both sides. So you get x squared plus 20x equals negative 100. And now that I have it isolated, I can start completing the square. We do that by taking whatever b is and dividing it by 2. Again, hold on to that number. It's going to play a very important role for us. Square that number to find out what the missing chunk is, right? So I'm basically at step 4 there. So we're going to square the number. Now what do? I come to my incomplete square and I complete it by adding, right, that missing chunk. So we get x squared plus 20x plus 100, and of course whatever I do to one side, I do to the other. All right, and this side factors now as x minus, what would that be? You know what, guys? Yeah, we're going to be okay. Right, this factors into x plus 10 squared, right, and it basically equals 0. So kind of a unique situation there. So everybody okay with my steps? Now what you've seen is I've built up a step where I can take the square root of both sides. I've introduced a plus minus. Of course, what is the square root of 0? It's 0. So we just basically have x minus 10 equals 0. So if I subtract 10, we find that this equation only has one true solution, x equals negative 10. Of course, we could finish that by plugging that in and seeing that it does actually 2, if I took negative 10 squared, that's 100, times 2 is 200, right? This would give us a negative 400, right? Because 40 times negative 10 and then plus 200. So 200 and 200 is 400. Take away negative 400, we get 0. So it does check out, and the math tells me that that's the only one. So kind of a unique situation there, but there is your introduction to completing the square. Obviously, we have a lot to practice. There's a lot of steps, there's a lot of craziness, but believe it or not, mathematically, this was the first way that they did this. And again, going off on a tangent, it's incredible because this was, you know, maybe 3 or 4 millennia ago. So we're talking 200, 300, 3000 or 2000 BC. Babylonians and Assyrians and the ancient Greeks, for whatever reason, were solving quadratics, and this is the first idea they came up with. So it's actually quite incredible. I sound like a nerd. I know I'm a nerd. You know, why were they even solving these? And man, who created this idea? Just a fabulous, incredible idea. All right, so let's practice this in some more videos.